Okay, welcome back, guys. To observe the time response, we have the standard systems, that is first order system. So in the systems, generally in a transfer function, the denominator of a the denominator order is said to be order of the system. That means we have for observation in our semesters we have first order system. So first order system, what is the first order system? And second order system. Okay, so to know what is first order system, I'll be taking one circuit, that is simple RC circuit, a series RC circuit, which is Laplace of this is 1 by Cs, and the input Laplace is, let us designate f of v of s, and the output I want to take is v naught of s. So by voltage division rule, we have v naught of s equal to v of s into 1 by Cs divided by 1 by Cs plus R. That means, so v naught by s by v input of s, so we will be obtained with 1 by Cs divided by 1 plus RCS by Cs. So these two get cancelled. So I will be having 1 by RCS plus 1. So further we will have 1 by RC by S plus 1 by RC. So in the denominator, this S term is powered by 1. So ultimately we have obtained so what is the transfer function means? It is output by input equal to the function we got. So that is called system G of S. So what I meant to say is that this entire circuit is a system. If we want to represent in a control system manner, so we have a system G of S, that is a series RC circuit with the input R of S, which is output, input is a voltage is input, and the response is we have the C of S is the response. Therefore, I have said this, if we replace the G of S with this circuit, then the G of S here is said to be a first order circuit, first order system. Okay. So, okay, you got the first order system. Now what we have to do? So we have to take the response. So I got the first order system like this. So to know the response, that is output is my response, right? So what is the input I am giving? So input I am giving a DC value. So the input I am giving the DC value means, that means I am giving the input as a unit step input. So my response is, so V of S, so I want the response V of S. That means I take the input in the other side and observe these calculations, that is 1 by RC divided by S plus 1 by RC. So my input is DC. The DC means a certain value, let us take amplitude A. So if I am taking input V of S, certain value of A, that means the Laplace of DC is step. So that means A by S, let us take, so I am giving a DC magnitude of A. The Laplace of that A is A by S. So if I substitute that here, I will having a value of A into 1 by RC by S into S plus 1 by RC. Okay. So if I take the Laplace partial functions, I will be having the value of, let us say small, so instead of unit, let us say I am taking input as unit input. Okay. So then my Laplace will be in the form of 1 by S. So my input is DC of 1 unit. Okay, unit step input. The Laplace of unit step input is 1 by S. Okay. So further, so if I do partial fractions, I'll be having of A by B by S plus 1 by RC. So the output response, so it should be in time domain, that is equal to Laplace inverse of V naught of S. I'll be having end up with a value of A plus B e power minus 1 by RC. So if I substitute this, if I want A and B values, what I'll do is, So a into s plus 1 by rc plus b s, which will be, so numerators of these two will be equal to what? 1 by rc. So substitute in the coefficients, comparing the coefficients of s a by b equal to 0 and the constant value 1 by a by rc equal to 1 by rc. So these two get cancelled, then a equal to 1 and b equal to minus 1. So if you substitute here, we will have the output response of t equal to 1 plus 1 minus of, if you substitute a in place of 1 and b as minus 1, we will having minus 1 e power minus 1 by rc into t. Okay, this is my response. So that, for example, if I have so with respect to t varying, what I'll get is, if t equal to 0, if you substitute here, so e power 1 minus 1 e power minus 0, so e power minus 0 means it will be 1, then equal to, so 1 minus 1, you will have a value of 0. If you substitute t to infinity, then 1 minus 1 into e power minus infinity, e power minus infinity is value is 0, so 1 minus 0 you will get 1. That means at time t equal to 0, the response across the capacitor is 0. That means if you substitute at infinite time, the response is increasing and reach to a value of 1. So my first order response, that means if I see the first order response is just only exponential. So for this I conclude the response of first order system is exponentially increasing, okay, and reach exponential values. So exponentially it is increasing, and in case another case, if the up till some source, if it is acting up to here, now suddenly the source is removed and the response again getting decayed. So exponentially increasing and exponentially decreasing is the character of response of the first order system. Okay, so the first order system is just simply given by this circuit, RC circuit. In the other form, if you want to describe the first order system, simply we'll say g of s equal to some a by s plus a. So this is a first order system. Okay, the value of a and a, small a and capital A may vary in different systems, or it may be equal in other systems. So this is a is said to be a gain of the system, and it's plus a and minus a. The a is said to be a pole of a system. Okay. So in the other way, we can also say that we have Laplace as s equal to what? So this is a complex number in Laplace domain. We'll have a real part plus j omega. So here real part is exponential part, and a is a sinusoidal part. That means here we have s plus a. So the root is a, though, okay, that means a we are having. So here if we have s plus a, that is the pole is minus a, that is only having a real part, so it is said to be exponential. First order is exponential, but the case in second order will vary. In second order we'll have exponential response, sinusoidal response, and a combination of exponential plus sinusoidal. Okay guys, thank you. We'll see in the next class about the second order response. Thank you.